Pluto, a tiny frozen world at the edge of our solar system. Once celebrated as the ninth planet, this enigmatic body has sparked debates, inspired imaginations, and challenged our understanding of what it means to be a planet. For generations, Pluto was the farthest frontier of the solar system, the lonely outpost at the edge of the known. But in 2006, everything changed. Pluto's status as a planet was revoked, and with it, a wave of controversy swept the world. Was it a demotion or a revelation? Yet Pluto refuses to be forgotten. NASA's New Horizons mission reignited our fascination, revealing a world far more complex than anyone had imagined. Icy plains, towering mountains, and a thin atmosphere. This tiny world held surprises that transformed how we see the outer solar system. So why does Pluto still captivate us? What do we know about this distant world, and what do we get wrong? As we journey into the mysteries of Pluto, we'll uncover the secrets of its past, its unique place in our solar system, and why it continues to hold a special place in our hearts. In 1930, a young astronomer named Clyde Tombaugh made a discovery that would capture the world's imagination. At the Lowell Observatory in Flagstaff, Arizona, he found what was believed to be the elusive planet X. The search for Pluto began with a mystery. Astronomers noticed irregularities in the orbits of Neptune and Uranus, gravitational tugs that hinted at the presence of an unknown ninth planet. Percival Lowell, the founder of the observatory, coined the term Planet X and dedicated years to the search, but he passed away in 1916 without finding it. It wasn't until Clyde Tombaugh, a 24-year-old farm boy turned self-taught astronomer, was hired to continue the search that progress was made. Armed with photographic plates and a device called a blink comparator, Tombaugh meticulously compared images of the night sky, looking for a single dot that moved against the background of stars. After months of painstaking work, Tombaugh spotted something extraordinary. A tiny speck of light shifted position between two photographs, a sign of a distant world. On February 18, 1930, Clyde Tombaugh officially discovered Pluto, a moment that would redefine our understanding of the solar system. Pluto's discovery was a monumental achievement, made even more remarkable by the technology of the time. With limited tools and no computer assistance, Tombaugh's dedication and sharp eye uncovered a world billions of kilometers away. At the time, Pluto was celebrated as the ninth planet. Its discovery validated years of effort and offered a glimpse into the mysteries of the outer solar system. For a brief moment, it seemed as though humanity had mapped the farthest reaches of the sun's domain. But Pluto's discovery wasn't just a scientific triumph. It was a testament to the human spirit, the pursuit of knowledge, and the drive to explore the unknown. It marked the beginning of a journey that continues to this day, as we uncover the secrets of this distant, icy world. For decades, Pluto was celebrated as the ninth planet, a distant, icy world orbiting on the outskirts of our solar system. Mention Pluto, and many people recall its place at the edge of planetary maps, nestled just beyond Neptune. In classrooms, Pluto was often depicted as a small, cold planet, distinct for its elliptical orbit and distance from the Sun. Its discovery in 1930 marked a monumental moment in astronomy, as scientists believed they'd completed the planetary family. Pluto's cultural impact extended beyond science. It captured imaginations through popular culture, from Disney's lovable dog to speculative depictions in sci-fi movies and television. For many, Pluto wasn't just a planet, it was a symbol of mystery and exploration. But how much do we really know about Pluto? For decades, it was a planet shrouded in mystery, with its true nature hidden behind the veil of distance and limited technology. What lies beneath its icy surface remained a question for generations. While Pluto may have seemed small and insignificant to some, its story was far from over. The more we explored, the more we realized how much we misunderstood this distant world. Pluto may no longer be classified as a planet, but it remains one of the most fascinating objects in our solar system. Beyond its diminutive size lies a world full of surprises, defying our expectations at every turn. One of Pluto's most distinctive features is its orbit. Unlike the nearly circular paths of most planets, Pluto follows an elongated, tilted orbit that crosses Neptune's path, taking it as far as 7.4 billion kilometers from the Sun. It also spins in a strange way. Pluto's axis is tilted by 120 degrees, meaning it essentially rolls around the Sun on its side. A single day on Pluto lasts over 6 Earth days, a reminder of just how different life would be on this icy world. Pluto isn't alone in its journey. It has 5 known moons, and its largest, Charon, shares a relationship unlike any other in the solar system. Together, they form a binary system, with Charon's gravity so strong that Pluto wobbles as they orbit a shared center of mass. Charon is no mere companion. It's massive enough to stretch and shape Pluto's surface, contributing to the dynamic forces at play on this icy world. Far from being a lifeless rock, Pluto boasts a complex and active surface. Its heart-shaped glacier, Sputnik Planitia, is made of frozen nitrogen that flows like ice on Earth. Towering mountains of water ice rise nearby, hinting at a robust geological history. Pluto's atmosphere, though tenuous, is rich in nitrogen, methane, and carbon monoxide. As the Sun warms its surface, gases escape, creating a temporary haze that surrounds the planet. But perhaps the most surprising discovery is the possibility of a hidden ocean beneath its frozen exterior. Warmed by internal heat, this subsurface ocean could be a sanctuary for life, an idea that transforms Pluto from a barren world to a tantalizing scientific target. Pluto's eccentric orbit, its intimate dance with Charon, and its active surface remind us that even the smallest worlds can hold the greatest mysteries. It may not be a planet, but Pluto proves that in the vastness of space, there's always more than meets the eye. Pluto has long been misunderstood. Even after its discovery in 1930, many of us believe things about this distant world that just aren't true. Let's set the record straight. Contrary to popular belief, Pluto isn't just a frozen, lifeless rock. While it is cold, with surface temperatures dropping to -375 degrees Fahrenheit, Pluto is far from inert. In fact, Pluto is a geologically active world. Beneath its icy surface, there's evidence of flowing nitrogen glaciers, towering ice mountains, and even cryovolcanoes, volcanoes that erupt with water or ammonia instead of lava. These dynamic features make Pluto one of the most intriguing places in the solar system. Scientists believe that Pluto might even harbor a subsurface ocean beneath its ice, a stark contrast to the lifeless rock many imagine it to be. This raises fascinating questions about whether it could support some form of life. Pluto's reclassification in 2006 as a dwarf planet doesn't make it any less important. Its demotion wasn't about its value, but rather about refining our definition of a planet. In fact, Pluto's status has made it a key to understanding the Kuiper Belt, a vast region beyond Neptune filled with icy bodies that hold clues to the early solar system. Studying Pluto helps scientists learn about the building blocks of planets, the dynamics of our solar system's outer regions, and even the origins of water and organic materials on Earth. So no, Pluto isn't a lifeless rock, nor is it unimportant. It's a dynamic, fascinating world that has reshaped how we understand our place in the solar system. Pluto's story isn't over, it's just beginning. In 2006, the International Astronomical Union, or IAU, made a decision that redefined how we classify planets. This decision demoted Pluto from the ranks of planets, sparking debates that continue to this day. But why did Pluto lose its planetary status? To understand Pluto's reclassification, we need to start with the IAU's definition of a planet. In 2006, the IAU outlined 3 criteria that an object must meet to be considered a planet.
First, it must orbit the Sun. Second, it must have sufficient mass to assume a nearly round shape. And third, it must have cleared its orbital neighborhood of other debris.
Pluto meets the first 2 criteria. It orbits the Sun, and its gravity is strong enough to shape it into a nearly perfect sphere. But it fails the third and most controversial requirement, clearing its orbital neighborhood. Clearing its orbital neighborhood means that a planet must dominate its region of space, gravitationally sweeping up or scattering away smaller objects. Mercury, Venus, Earth, and the other planets meet this criterion. They've cleared their paths of debris over billions of years. Pluto, however, shares its orbit with thousands of other icy bodies in the Kuiper Belt. It's just one of many objects in a crowded region of space. Pluto's orbit is also highly eccentric and tilted, unlike the relatively flat, circular orbits of the planets. At times, Pluto is closer to the Sun than Neptune, further distinguishing it from the 8 planets in our solar system. The IAU's decision wasn't just about Pluto. It was about refining our understanding of the solar system. By clearly defining what makes a planet, scientists can better categorize the thousands of objects discovered in the Kuiper Belt and beyond. Pluto is part of a fascinating family of dwarf planets, smaller worlds that give us insight into the early solar system and the processes that shaped it. While Pluto may no longer be a planet by definition, it remains one of the most intriguing objects in the solar system. Its demotion wasn't a loss. It was a step forward in understanding the complexity and diversity of our cosmic neighborhood. Pluto's journey from the 9th planet of the solar system to a dwarf planet sparked a controversy that transcended science. It wasn't just astronomers debating its fate. It was the public, students, and pop culture icons rallying around this icy world. Why does Pluto matter so much to us? Pluto's symbolic importance lies in its story. For decades, it was the distant, mysterious 9th planet, a reminder that our solar system extends far beyond what we can see. It was the underdog of the planets, small and unassuming, yet full of intrigue. Even after its reclassification as a dwarf planet, Pluto remains a cultural icon. It represents our curiosity, our desire to explore the unknown, and our willingness to question what we think we know about the universe. But Pluto is more than just a symbol. Its reclassification fueled renewed interest in the Kuiper Belt, a vast region of icy objects at the edge of our solar system. It made us ask new questions. What else is out there? What secrets do these distant worlds hold? Pluto isn't just a conversation about what makes a planet. It's a gateway to understanding the outer reaches of our solar system. Its mystery drives us to explore further, pushing the boundaries of science and discovery. Pluto may have been redefined, but its story continues to inspire. It reminds us that even the smallest worlds can have the biggest impact on how we see the universe and ourselves. For over 75 years, Pluto was celebrated as the 9th planet in our solar system, a distant yet integral member of our cosmic neighborhood. But in 2006, everything changed. The IAU introduced 3 criteria to define a planet. It must orbit the Sun. It must have enough mass to be nearly round in shape. It must clear its orbital neighborhood of other objects. Pluto met the first 2 conditions, but it failed the third. Its orbit overlaps with other icy bodies in the Kuiper Belt, a region filled with small frozen objects beyond Neptune. And so, Pluto was reclassified as a dwarf planet. This decision sparked global debate. To many, Pluto's demotion felt personal, a loss of an iconic member of the solar system. Yet, the change marked a turning point in how we view and classify celestial objects. Though no longer a full-fledged planet, Pluto remains scientifically significant. It's one of the largest known objects in the Kuiper Belt, a vast region of icy bodies that holds clues to the early solar system. By studying Pluto, scientists can better understand the building blocks of planets and the processes that shaped our cosmic neighborhood. In 2015, NASA's New Horizons mission revealed Pluto's astonishing complexity, a world with active geology, a thin atmosphere, and a history shaped by collisions and interactions with the Kuiper Belt. Pluto's reclassification didn't diminish its importance. Instead, it opened the door to a broader understanding of the solar system, one where planets, moons, and dwarf planets each play a vital role. Far from being forgotten, Pluto reminds us that the boundaries of science are constantly evolving, challenging us to rethink what we know about the universe. In 2015, after a 9-year journey spanning over 3 billion miles, NASA's New Horizons spacecraft reached Pluto, a moment that transformed our understanding of this enigmatic world. What it revealed was a planet far more dynamic, complex, and alive than we ever imagined. One of the first discoveries to captivate the world was Pluto's heart, a vast glacier of nitrogen ice called Sputnik Planitia. Stretching over 1,000 kilometers, this icy plain glows brightly against the darker surrounding terrain, symbolizing Pluto's surprising diversity. Unlike the heavily cratered surfaces of other icy bodies, Sputnik Planitia is remarkably smooth. These polygonal patterns suggest active convection, where heat from Pluto's interior circulates through its icy crust, reshaping the surface over time. This is no frozen relic. It's a living, dynamic world. Pluto's geology stunned scientists. Towering ice mountains as high as the Rockies rise across its surface, alongside deep valleys and expansive plains. Evidence suggests that beneath its icy crust lies a hidden ocean, a reservoir of liquid water kept warm by the slow decay of radioactive materials in its core. These findings challenge our assumptions about small, icy worlds. Pluto isn't a static, frozen rock. It's geologically active, potentially harboring the conditions for life in its hidden depths. New Horizons also uncovered Pluto's delicate yet dynamic atmosphere, composed mainly of nitrogen, methane, and carbon monoxide. This thin layer creates a stunning blue haze when sunlight interacts with atmospheric particles. Even Pluto's surface colors defy expectations. Reddish hues come from tholins, complex organic molecules created when solar radiation interacts with methane on its surface. These surprising colors hint at chemical processes that are still active, painting Pluto as a world full of surprises. Before New Horizons, Pluto was little more than a distant speck, a faint dot in the vastness of space. Its discovery revealed a world brimming with complexity, rewriting everything we thought we knew. New Horizons didn't just reshape our view of Pluto. It redefined our understanding of the outer solar system. As a member of the Kuiper Belt, Pluto is now seen as a key to studying how icy worlds form, evolve, and interact with their environments. After its historic flyby, New Horizons continued to send back data for over a year. Each transmission carried a piece of Pluto's story, connecting a distant, icy world to the imaginations of people on Earth. New Horizons reminded us of the power of exploration, the ability to transform a distant mystery into a tangible, awe-inspiring reality. What New Horizons discovered around Pluto is more than a collection of scientific facts. It's a testament to the beauty and complexity of the universe and a reminder that even the smallest, most distant worlds have stories worth uncovering. Pluto may no longer be classified as a planet, but its story is far from over. Its icy plains, towering mountains, and mysterious atmosphere have captivated us for nearly a century, fueling debates, discoveries, and dreams. This tiny world, more than 5 billion kilometers away, has shown us that even in the farthest reaches of our solar system, there are wonders waiting to be discovered. It's a reminder that the universe is vast, complex, and filled with surprises. Pluto stands as a symbol of human curiosity, of our determination to explore and understand the unknown. From Clyde Tombaugh's careful observations in 1930 to the groundbreaking discoveries of New Horizons, Pluto has continued to challenge our perceptions and expand our knowledge. But Pluto is more than a single, fascinating world. It's a gateway to an entirely new frontier, the Kuiper Belt, a region teeming with ancient relics from the formation of our solar system. By studying Pluto, we've begun to uncover the secrets of this distant realm, piecing together the story of our cosmic origins.
And yet Pluto is more than just science. It inspires us, reminding us of our ability to reach beyond what we thought possible. If this icy world, smaller than Earth's moon, can surprise us, what other secrets await in the unexplored corners of our solar system?
Pluto teaches us that the universe is never static. Every discovery leads to new questions, new mysteries, and new horizons. It challenges us to keep exploring, to keep dreaming, and to embrace the wonder of what lies beyond. In the end, Pluto is not just a destination. It's a beginning, a reminder that our journey into the cosmos is far from over, and that even the smallest worlds can have the biggest impact on our understanding of the universe.